Section 2.7, more application problems. All right, so let me get this out of the way right here. Percent means per 100. So if I have something that involves a percent, it has to get multiplied times something. The percent always has to get multiplied times something. And you always write it as a decimal. Percent is always written as a decimal. If I'm trying to figure out an amount of discount, you take the original price and you multiply it times the discounted rate or the percent of discount. What else? When we have a mixture problem, you take the base, multiply it times the rate. Interest problems, interest is equal to principal times rate times time. You always multiply the percent times something. So it asks how much, hold on, sorry about that. How much pure acid is in 40 liters of a 16% acid? So basically what this is saying is 16% of 40 liters. What is 16% of 40 liters? We can do this the way we were doing it in the last section, where we can set it up as a proportion, or we of means multiply. So if we just take 16% and multiply it times 40, and I'm going to grab a calculator, we have 0.16. Remember to write the percent as a decimal. Times 40 times 40 is 6.4. And so this would be the amount of acid, 100% acid, in the solution, acid solution. Annual simple interest, formula, principal times rate times time. So interest is going to be equal to our principal, this is how much we are investing, times our interest rate written as a decimal, 0.04, times time. Now, the time is in years and it says annual, so we're just doing it for 1 year. So we're going to multiply those together, 5,000 times 0.04 times 1 gives us $200 in simple interest. All right. Okay. You can set up mixture problems a couple different ways. You can set it up as a table. I prefer buckets. It just seems to be a little bit more intuitive if you use buckets. So when you have a mixture problem, you know it's a mixture problem because you see the word mixed right here, mixed. So when you have a mixture problem, you're always going to have, you're going to draw 3 buckets, and you're going to put a plus sign between the first 2 buckets and an equal sign between in the last bucket. Okay. So inside the bucket goes the amount, and outside the bucket goes the rate, the percent. Okay, usually it's a percent. It doesn't have to be a percent, but it's some sort of rate. So it could be a per pound or it could be a percent, but it's going to be some sort of rate. Inside is an amount, and outside is going to be the percent. Inside is the amount. Now this last bucket is your mixture. Okay, so we're going to take 2 different buckets and we are going to pour them together and end up with a mixture right here. Okay, so that's why we're adding the 2 buckets together, because we are combining them. All right, and outside the bucket, sorry, goes the percent or the rate. All right, so in this particular problem, a certain metal is 40% copper. Okay, so We don't know. It says how many kilograms of this metal. We don't know how many. We don't know the amount. But we do know it is 40% copper. Write it as a decimal. Must be mixed with 80 kilograms. That's an amount. We're going to put it inside the bucket of a metal that is 70% copper. It's a percent. It goes outside the bucket. We're going to get a mixture. We're going to add these two together and get a mixture that is 50% copper. Now, right now, we have used every single number that's up there, but we have not filled in the amount here. So if I have an amount here and an amount here, notice that I put that plus sign there deliberately. So if I have 10 plus 80, how many am I going to have in my mixture? Well, that would be 90 because I'm going to add them together. If I have 20 plus 80, I would have 100, 30 plus 80, etc. So I don't know what this is, but I do know the mixture has to be whatever that quantity is plus the 80 that I have right here. All right. Now, remember how I said you always take the percent and you multiply it times the amount. So we're going to multiply these two together. So 0.40x plus, we're going to multiply these two together. The percent always gets multiplied by the amount is equal to, we're going to multiply these two together, but this is two terms, so we have to put it in parentheses. 0.50x plus 80. All right. Now, I am going to go to the next slide because I've kind of run out of room to solve this equation. So I'm going to go to the next slide. Hopefully, yes, it is simplified a little bit. Notice instead of putting 0.40, I did that deliberately here so that you could see where this number goes and this number goes and this number goes. But in general, if I have an end zero like this, I don't write it. So my end zero, I have gotten rid of in each of those three places. Now, we do have a decimal here, here, and here. So all three terms have a decimal. And we have one decimal place right here. So if you recall from a previous video, I don't remember, I think it's section 2.3, in order to get rid of the decimal, if we have to move one decimal place, we would multiply by 10, by 10, and by 10. So this will give me 4x plus 7 times 80 is equal to 5 times x plus 80. All right. Now, we're going to simplify this. We're going to multiply these together, and we're going to distribute the 5. So 4x plus 560, multiply, I get 5x, and multiply, I should get 400. Okay. This x is bigger than this one, so I'm going to subtract this one to leave it as a positive x. So 560 is equal to x plus 400, and I'm going to subtract 400, and I get 160. Now, we got to go back to the original problem, make sure we actually answer the question. So it says, how many kilograms of this metal? So we're trying to find that. And we found x to be 160, and it was in kilograms. So we have 160 kilograms of our 40% copper. All right. How many gallons? Again, we have a mixture of a 12% indicator solution must be mixed with a 20% indicator solution to obtain 10 gallons of a 14% solution. All right, so we're going to draw our 3 buckets. I cannot draw to save my life, so I just draw my buckets like this. It doesn't have to look like a bucket. But as long as I have some place to put something inside, and I'm going to put my percent on the outside. So how many gallons? I don't know what that is. 12% solution, percent always goes outside the bucket, must be mixed with A 20% solution, okay, that's a percent, it's going to go outside the bucket. To obtain 10 gallons, that's an amount, and it is a 14% solution. Notice, pay particular attention. In the first example we didn't know what this one was, but in this one we don't know what this one is, okay? Makes a huge difference. We do not add x plus 10 to get this number. We take x plus this number to get 10. X plus this number to get 10. So to figure out what that number is, it's going to be, this number is going to be 10 minus x. Be careful, be really careful that you do not do x minus 10. Make sure you do 10 minus x. If you recall when we were talking about, I think it was angles, and I always said it's always the total minus x. If you know the total, it's the total minus x, 10 minus x. All right, once we get to this point, we're going to set up our equation. We're going to multiply, multiply, multiply. So 0.12x, 0.20, 10 minus x, 0.14 times 10. And this time I have 2 decimal places, so I'm going to multiply by 100. So I have 12x plus 20 times 10 minus x is equal to 14, there's my 1, times 10. Okay, we're going to distribute. So 12x plus 200 minus 20x is equal to 140. Combine like terms. Negative 8x plus 200 is equal to 140. Subtract my 200. I get negative 8x is equal to negative 60 and divide by 8. Negative 8, sorry. Negative 8. 8 does not go into 60 evenly, so I want you to write it as an improper fraction. 4 goes in though. Negative, positive. A negative divided by negative is positive. 15, 4 goes in there too. Because this is a word problem, and we started with decimals in the original problem, I'm going to say in this case it's an acceptable time to give a decimal answer. Gallons. I would take either one of these for this problem. Oh, we already solved it on the last slide. Okay. All right, simple interest. Remember the formula for simple interest, principal times rate times time. Okay, with income earned by selling a patent, and this is technically a mixture problem, but I generally don't do buckets for this one when we're doing with interest. This one I generally do a table. And so my first column is going to be my principal, and then my rate, and then my time, and the final column is going to be interest, because you know that principal times rate times time is equal to interest. So these are going to be my columns. Like this. Okay. An engineer invests some money at 5%. Okay. So here is going to be, I'm going to label this as my 5% account, and my interest rate for my 5% account is 5% as a decimal 0.05. And we don't know how much it is. We're going to call it X. And be careful with this one. It's not 3,000. It's 3,000 more than twice as much. Okay, so here's my 8% account, which our interest rate is going to be 0.08. 3,000 more than, 3,000 more than twice as much. Twice means 2 times. Okay. Annual, so that would be for 1 year. And we end up with a total of $1,710. So what we're going to do is the interest that we earn in this account plus the interest that we earn in this account is going to give us a total. Remember what I said about total? It means you add them up. It's going to give us a total of $1,710. Okay, so we have to find the interest for our 5% account. To find the interest, we multiply these together. X times 0.05 times 1. So we multiply these together. Remember, principal times rate times time. And we're going to add the interest we earn for our 8% account. So we're going to multiply these as well. So 0.08, and don't forget this has two terms, so I have to put it in parentheses, plus 2x. Okay, so here's my equation. I have this plus I have this, and it's going to equal that. And yeah, I'm going to go to the next slide so I have room to work it out. Yeah, here's my equation. So again, I have decimals, 2 decimal places. So I'm going to multiply by 100. Be super careful when you multiply by 100 because you have to multiply every term that includes the 1,710. Even though this one doesn't have a decimal, you still have to multiply by 100. So 5x plus 8 times 2x plus 3,000 is equal to 1,710, and then multiply by 100. I'm going to put 2 more zeros. All right, so we're going to solve it. We're going to distribute the 8. So 5x plus 16x plus 24, 3 zeros, 171, 3 zeros. Combine like terms, 21x, 171, and subtract. So 21x, I don't know what 171 minus 24 is. 171, 147. And we're going to divide that by 21. And we get 7,000. So x is equal to 7,000. Now, again, we have to go back to our original problem, make sure we actually answer the question that's asked. So it says, find the amount invested at 5%. Well, the amount invested at 5% was our x, which we decided was 7,000. Okay. The question could have asked, how much did we invest at 8%? In which case, 2 times our 7,000 is 14,000, plus 3,000 would be 17,000. Okay, you just got to read the question, see which one it's asking for. Okay, could be either one or could be both. Just got to read the question to see what it is asking for. All right, I am going to stop the video here, and I'm going to pick it back up in another video, part 2.